All right, these next three I'm going to take all together, question 7, question 8, and question 9, because they all deal with the same chemical reaction. So we're combining N2 gas, H2 gas, to make ammonia. And in all three cases here, since it's the same reaction, it has the same enthalpy change. And the number here doesn't really matter to us. What matters is that negative sign. This negative sign means that these reactions are exothermic. And how that's important for us here, that means heat is a product of the reaction. Okay, for an exothermic reaction, heat is a product. And so we can treat it just like adding a product. So in all ways, shapes, and forms will be just the same as adding ammonia. It'll have the same effect that we would have if we added in ammonia, which is a chemical product. All right, so for the first one here, which of the following at equilibrium which change will cause the equilibrium to shift to the left, back toward the reactants? Decreasing the volume of the container. No, that won't work. So decreasing the volume of the container actually makes it go right, because we have 4 moles of gas going into 2 moles of gas. 4 moles become 2 moles. So decreasing the volume actually makes it go to the right, so that one doesn't work. Removing some ammonia. So if I remove ammonia, N2 and H2 get used up to make it. So when I remove ammonia, it makes more ammonia. So removing ammonia does not make it shift to the left. If I add H2, it gets consumed and made into ammonia, so it goes to the right. If I add N2, same deal. If I decrease the temperature, well, that one's interesting. So temperature is a product, since it's an exothermic reaction. So if I add in temperature on this side, if I add in heat, it will make the reaction go to the left. It will decrease the temperature. It will decrease. Okay, and it does that by changing the equilibrium constant. So temperature is the one and only thing in the universe that changes Kc. All right, same reaction again. Going to ask another question about it though. For the following reaction at equilibrium, which change will cause H2 concentration to decrease? So what will make the H2 concentration decrease? Increasing the temperature. Well, heat is a product, so if I increase the temperature, I get more H2, so it's not that one. If I add ammonia, I get more H2, so it's not that one. If I remove some N2, ammonia breaks down and makes more N2 and also makes more H2, so it's not that one. Compress the mixture. Well, that one's interesting. So if I compress the mixture, 3 moles of gases go to 2 moles of gases. So compressing the mixture will make the reaction go to the right, and that will use up some H2 and some N2. So compressing the mixture. And a catalyst does absolutely nothing to the equilibrium. So not a catalyst. The next one here, for the equilibrium reaction, again, which of these factors would cause the equilibrium constant to increase? Well, I don't have to think about this one too much, because temperature is the only thing that can affect the equilibrium constant itself. So temperature, let's see if we agree. So temperature is, heat is a product. If I pull that heat out, it will make the reaction go to the right. So it will increase the Kc. So yeah, that all makes sense.